Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Unsupervised Learning, Finding Hidden Patterns in Data. Hey everyone, Chaitanya here, and today we're diving into a super cool part of AI called unsupervised learning. Imagine you're a detective, but instead of solving a crime with clear clues, like in a mystery novel where the author tells you who the bad guy is, you're just given a huge pile of evidence, photos, notes, phone records, with no labels. No idea what's connected. Your job is to find patterns, groups, or unusual things all by yourself. That's unsupervised learning in a nutshell. It's about letting the AI find hidden structures in data without us telling it what to look for. You might have heard about supervised learning before. That's when you teach AI by showing it examples with clear answers. Think of it like training a puppy. You show it a sit command, and when it sits, you give it a treat. You supervise its learning by providing labels. Good sit, bad sit. In supervised learning, our data comes with labels. E.g., this email is spam. This image is a cat. Unsupervised learning is different. We feed the AI raw, in labeled data, a huge collection of emails without any spam tag, or tons of images without any cat or dog label. The AI has to figure out the categories or patterns on its own. No supervisor, just pure exploration. One of the most common jobs for unsupervised learning is clustering. Imagine you own an online store and have a huge database of customers. You don't know who likes what, but you want to send targeted ads. Clustering is like telling your AI, go through all my customer data, their purchase history, browsing habits, location, and group similar customers together. The AI might find groups like gamers who buy new releases frequently, budget shoppers looking for discounts, or luxury buyers interested in high-end items. As a developer, you could then use these clusters to tailor your app's recommendations or marketing campaigns, all without ever manually labeling a single customer. So, how does an AI actually cluster data? Let's take a common algorithm called k-means. Imagine you have a bunch of dots on a graph. Your data points. You tell the AI, I want to find k number of groups, e.g., 3 groups. The AI randomly picks k central points. Then, it goes through every data point and assigns it to the closest central point. After all points are assigned, it recalculates the center of each group based on its members. It keeps repeating this assign and recalculate process until the groups become stable. From a developer's perspective, you'd feed your data into a k-means function, specify !k and it would return a cluster ID for each data point, like !cluster underscore id, 0 !cluster underscore id, 1 etc. Ready for you to use. Another powerful use for unsupervised learning is anomaly detection. Think about credit card fraud. Banks process millions of transactions every day. Most are normal, but a few are fraudulent. It's impossible to label every transaction as fraud or not fraud beforehand. Instead, banks use unsupervised learning to learn what normal transaction behavior looks like. If a transaction suddenly deviates significantly from this learned normal pattern, say, a small purchase suddenly followed by a huge one in a foreign country, the AI flags it as an anomaly or potential fraud. As a developer, you could implement this to monitor server logs for unusual activity, detect manufacturing defects, or even find sick patients based on their vital signs. Sometimes, our data has too many features or dimensions. Imagine you have a dataset about houses, with hundreds of data points for each house. Number of rooms, square footage, garden size, age, number of bathrooms, type of roof, wall color, etc. Working with all these features can be slow and confusing for AI models. Dimensionality reduction is like compressing a large file without losing the most important information. Unsupervised learning algorithms can find the most important underlying dimensions or combinations of features that capture most of the data's essence, letting you work with a much smaller, simpler dataset. For a developer, this means faster training times and potentially better model performance, especially when dealing with complex datasets like images or text. So, why is this important for you as a developer? 1. Unlabeled data is everywhere. Most real-world data is unlabeled. You can't always pay someone to categorize everything. Unsupervised learning helps you get insights from it directly. 2. Data exploration. It's a fantastic first step for understanding your data. Before building a complex predictive model, you can use unsupervised methods to see inherent groups or outliers. 3. Feature engineering. The clusters or reduced dimensions found by unsupervised methods can become new, powerful features for supervised learning models, improving their accuracy. 4. Problem solving. From recommending products to detecting cybersecurity threats, unsupervised learning offers powerful tools to solve real-world problems where clear labels are scarce. It expands your AI toolkit significantly. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.